fun. Let's find the perimeter of this figure pictured below. The upper curve is defined as this parabola, and the lower is defined as y equals 1/2 x plus 2. So we have a line, we have a parabola, and then obviously we have these vertical lines. So we're dealing with the perimeter, and the perimeter is when you add up the length of all the sides. So normal, sort of normal, normal. Oh my goodness, I need the arc length formula. Now, I'm going to use the arc length formula for this, although I really could. Let's use our imaginations here. I could use the Pythagorean theorem. See? Totally could. Actually, I might. It would just be fun if I did. But it is an arc length lesson, so we'll do it. Let's deal with, we'll call it left, bottom, right, and the awkward little top here. Okay, so we're going to do left plus bottom plus right plus the awkward little top here. Okay, the left side, and we're dealing with the length of each of these, so don't make it harder than it is. The left side is 1, 2, 3, 4 units long, and if you need some level of proof about that, you can find points of intersection, like maybe the graph is lying to you. Maybe this is not exactly at -2, +1. Oh no, what would we do? Well, I'm telling you what we'd do. We would plug in a -2 into this equation, and in plugging in a -2, we would get a value of +1. So we do know this point is exactly at -2, +1. We also know that this point is, actually tricky, 3 comma something. And that 3, we plug in a 3, we get 1.5 plus 2, so it would be 3.5. It looked like 3.5, and it truly was. This point right here, if I plugged in a 3 into the parabola, I would have 9/2. That is 4.5 plus 3. So that is 7.5. It looked that way, and that is what it was, 3 comma 7.5. And then this dot right here is truly what it looks like. Plug in a -2 into the parabola. Plug in a -2, you would get 0. Yeah. -2 goes there, and wait a minute. No, it's not 0. That's not the x-axis. Wow. 5. My goodness. I was like, this doesn't work. Yes, it does. It's 5. Okay, got it. Wow, took me way too long. I'm like, that looks like the x-axis, but that can't be right. All right, we have what we need. Let's add together the length of the left, the bottom, the top, and the right, and I read them in a different order. So yeah, bless my heart. Let's write in red to make it stand out so I don't make mistakes. The left side is 4 units long. The bottom of this, we can use, and this is fun, we can use the arc length formula. Now again, we could also use the Pythagorean theorem. You're going to get the same thing either way. We're going to explore the use of the Pythagorean theorem versus the arc length formula on the next problem. We'll do that one on the board, but in the meantime, let's just use arc length for this one. The integral from -2 to 3. -2 to 3 of the square root. I'm using this formula right here. 1 plus, okay, what's the derivative of this? Well, 1/2. Okay, don't make it harder than it is. 1/2. Square it. dx. Now, isn't that 1/4? And then 1 plus 1/4, it'd be 5/4, and you square root, and yeah, do it by hand if you want to. I'm not. And then the right-hand side is, well, it goes from 3.5 to 7.5, so it must be also 4. And then the top, this one truly is trickier. So we're going to go from, we could say 3 to -2. Let's not. Let's go -2 to 3. Let's not make life complicated. And it's 1 plus the derivative of this parabola. And the derivative of this parabola is x, 1 plus 0. So x squared. And then I drew my square root symbol just a wee bit too long. And let's really just type it in the calculator. There are some that we will do by hand. This is not one of them. We could do this one by hand-ish, but let's not. Could use the Pythagorean theorem on it, like I said, like twice already. 4 plus, math none, -2 to 3, square root of, I'm just going to call it what it is. This is 1 plus 1/4. That would be, well, 1 1/4. No need to square anything. We just took care of some stuff in our head. Just be careful. Plus the other 4. Put those together, make an 8 if you like. obviously. And then negative 2 to 3. And then the square root of 1 plus x squared dx. All right, looking at my work, making sure I'm not accidentally lying to you here. And I don't think I am. I think we got it. I think we got it. Yeah. Okay, here's the perimeter. 22.201. The perimeter of this is 22.201 units.